Example 1 says, what is the missing side length in this right triangle? So we're going to use Pythagorean's theorem, which says a squared plus b squared equals c squared. It's a pretty famous theorem. So it doesn't matter what you call a and b. We just know, I think it has a question mark here, just know that our hypotenuse has to be c. And our hypotenuse is always the side opposite of our right angle. So I'm going to call 9a, and I'm going to call 12b. So we should have a squared plus b squared equals c squared, and we don't know c squared yet. But a is 9, so we're going to do 9 squared plus b, which is 12, and it's going to equal c squared. Okay, 9 squared is 81, and 12 squared is 144, and it still equals c squared. We don't know what that is. Okay, 81 plus 144 is 225. And 225 equals c squared. So we haven't quite solved for c yet. We solved for c squared, but not for c. And how we solve for c is to get rid of that squared, we have to take the square root, and they cancel each other out. But remember, we have to do the square root on this side too. So in your calculator, if you do the square root of 225, it's 15. So 15 equals c. And that's our answer. Okay. And 15, or your hypotenuse is always your longest side. So this 15 should be longer than 9 and 12. And it is. So let's come down here. Let's do a little bit of a harder one where there's 2 triangles involved. And it says, what is the length of side PQ in this figure? So we want to find this length here. That's PQ. So we don't know. But we don't really have a lot of information to solve that yet. So we're going to look at this triangle here, this blue one. We can call it a... Well, there's not a letter there, but this blue one here. So we have 3 on the side. We don't know the length of this side, but our hypotenuse is 5. So I'm going to say this is my A. I will say this is B. It doesn't matter what A and B are, but since 5 is opposite of my right angle, this is my C. I'm going to call this B. So let's find out what b equals here, and then we can use that side to help us find that yellow highlighted portion. Okay, so 3 squared, that's my a, plus, we don't know what b is, so we have b squared, equals c squared, and c is 5. Okay, so 3 squared is 9, plus b squared, we still don't know what that is. But 5 squared is 25. Okay, we want to solve for b, so we're going to do the inverse operations here. So this is a positive 9. So we're going to do the inverse and subtract 9 from both sides. And now we have b squared equals 25 minus 9, which is 16. And just like we did above, to get rid of the squared, we're going to take the square root of both sides, and the square root of 16 is 4. So b equals 4. That's not our answer yet, but b equals 4. Now we can look at this, we'll make it a red triangle here, and we can solve for PQ. But we only knew one side, we only knew this 6 before, And we need to know two sides to find the yellow side. So now we do. Now we know that that side is 4. So this is our hypotenuse, that PQ. So we're going to call it C. I'll call 6A. My B can still be 4, and then we'll find our C. So we're going to do the Pythagorean theorem again. So this time we have 6 squared plus 4 squared equals C squared. 6 squared is 36 plus 4 squared, that's 16, equals C squared. 36 plus 16 is 52. 52 equals C squared. And then again, to undo that square, we're going to take the square root of both sides. So C equals the square root of 52. And you can put that in your calculator to find the decimal form, but this should just be fine, leaving it this way. So actually our answer would be PQ equals the square root of 52. And it's okay if it's not a whole number. It can definitely be a decimal. But let me make it smaller so you can see both of those questions. Yeah, take your time. Just make sure you label everything. I would draw this on a piece of paper.